Hello, this is homework 9, exercise 9. We are given that x is a sequence of independent variable and yn equals to the sum of x, and we are going to prove if yn is a Markov chain. So for this question, we firstly we need to get started into the conditional probability like here, right? So we take x into this expression and y n plus 1 is equals to the summation of x I, right, from 1 to n minus n plus 1, and so it equals to the summation of xi from 1 to n plus xn plus 1, right? And here this term is equals to yn. So we could write yn plus 1 as xn plus 1 plus yn. Yes, and for the next step, we write two terms of y together, so xn plus 1 equals to yn plus 1 minus yn. Here that is capital Y here, and also we could write it as the lowercase yn. Yeah, since lowercase yn is a, should I say, we take all those lowercase xi as the value of the random variable x, and then we sum all those lowercase value together, we get the lowercase y. So that is the value of yn at that time. So capital Yn is like, why we could write capital Yn to lowercase yn is since we are compare those actual value of y, so we need to take specific value of small lowercase x, and then we get the lowercase y, so they are equal now. We could write it as lowercase yn, and since they are independent, we yn plus 1 is equals to from 1 to n. We could write it as yn plus xn plus 1, right? Here x is also the lowercase. Since we know that x is independent variable, so there is nothing to do with yn and xn plus 1. So since xn plus 1 is independent from terms of n minus 1 to 1, so yn and yn plus 1 is also independent. So here, that's why there is a lot of terms here of this condition. That's why we could ignore all those other terms here, since there are now since the probability is doing things with n plus 1 terms and n terms, so we could ignore all other terms for the conditional. That's why we only left yn equals to lowercase yn here, right? Makes sense. And then we change the x n plus 1 plus yn equals to yn plus 1, and now we write it back as y, capital Y n plus 1 here, like this. So they are the same, right? And from this expression and the first expression, we could see that it is a Markov chain's characteristic, and then we could conclude that y random variable y is a Markov chain. This process is a Markov chain. Yeah, I think it's enough for this question.